From the world of AV programming and control with James King, I'm Steve Greenblatt, and this is Ask the Programmer. James, how are you today? I'm glad we're back, and we got a fun episode planned.
Yeah, Steve, I'm glad to be back. And how are you doing?
I'm doing well. I'm we talked a couple episodes ago about a term called bloatware. So that's something that means different things to different people, and figured why don't we talk about that a bit today? So it's a little bit of a technical term that has different definitions to different people, and but we'll dive in and see where we go with it. So when you hear that term, what do you think of, and what's the the implications of bloatware to you?
When I hear the word bloatware, I always what flashes in my head is the scene from Home Alone where Kevin throws the cologne on and screams in the mirror. Um, Bloatware is a scary term, scary because we know I mean, let's get to why we have bloatware. We have bloatware because, at least my understanding is, the programmer, the developer is trying to solve many problems in many scenarios with one solution. So they throw a lot in there, which then tends to slow down the processing because it's trying to handle every case scenario and be a Swiss Army knife to what everyone needs. And sometimes that leads to being, bulky and slowness and cumbersome. So that's really what I would say bloatware is to me. Before we even dive more into that, like, what does it mean to you, Steve?
Yeah, I like your definition. I would agree that it's trying to do more than you actually need to solve the problem or address the need for the particular application that you're developing. So, what I've seen in a couple of forms, one is when you write what people say is we have a template for a system, and like you said, it accommodates all the different scenarios and all the different variations of a system, and it's all in this one program, and you have to just implement a subset of it, but you leave all of the stuff that you don't need within the code. That's one thing, and which makes it very difficult to manage and troubleshoot and maintain, and also to modify. The other thing is when you're and part of this conversation came from a recent episode that we had, where we talked a little bit about modules and drivers and how you put in some block of code that is meant to work with a device or meant to provide a particular functionality, but it does so many other things that it weighs down the processor, as you said, and so I would agree with your definition of it, and it's actually becomes even more magnified when you're trying to make that system be even bigger or use multiple instances of the same um, module, let's call it, or block of code, because now you're multiplying the weight that you have on the processor.
Oh, no, that's definitely a good definition you have there. And like, that's how we see bloatware.
The question is, why does it exist? Well, I guess we know why it exists, because it's there's trying to be a universal solution, like you said, and also there may be a little bit of laziness, but are there benefits to an approach? So is there a trade-off when you say, um, we have something in here, it may be a little bit bloated, but it gets us to where we need to be? When does it become a good thing or an okay thing?
I think it becomes a good thing in scenarios that we may not even think about. Like we're we're programmers, so we don't always think about the needs of how this could be a great beneficial to our users. But think about it this way. I work in higher ed. If I wasn't a programmer and say my classrooms were using brand A displays, and the programmer who wrote that only wrote it for brand A displays, and then you know what? I gotta save some money. I'm gonna go buy brand H display, and it doesn't work. Now I got to pay for a program to fix it. Well, then you tell the program, like, hey, I want to be able to use any display manufacturer out there. And we all know there's tons of them out there. So I'm like, I don't know what I'm switching to tomorrow to make it work for everybody. Well, that makes the user life easier to be able to say, okay, I'm using brand A this time. Oh no, this time I'm using brand H. This time I'm using brand J. But that leads to the bloat of the program because you got to handle drivers for every single display manufacturer out there. And then those drivers have to have all those features subsets of those displays.
That's a great example of that. I've worked in systems like that, and I can see where the benefit is. And I think part of that is when you're trying to develop a solution like that, you have to be aware and come up with different ways, maybe of managing the the overhead that provides, and not introducing problems that, like you mentioned. Um, the Part of another scenario that I would see is that um, systems tend to get a little bit cumbersome when you're trying to just do too much. you know, so we you know keeping it simple sometimes is best, and when we're trying to make something work in too complex of a manner, or we're also making so many changes and modifications, code tends to um, get almost like a ball of yarn and get all twisted and tied up, and you could end up having a very bloated program in that regard. Um, but the flip side of that is the fact that, and my company does this, is that when you're writing a module or a driver or a plugin for a product, a lot of times you need to make sure that you're not necessarily including every single function, but you're including the majority of functions that are needed, because you don't want to be in the field and be missing that one function that you need to be able to get a project signed off, or that the user requested at the last minute, or that um, needs to be provided that wasn't thought of. So there's that's one reason why you might have some unused code, or a little bit of extra fluff, if you will, because you need to be flexible with AV systems. As we know, they tend to grow and morph, and a lot of times we don't get the luxury of knowing exactly what needs to be done when we first start. It could be an evolution of programming over time.
Oh, agree. And we all, as programmers, we tend to do that. And we throw things in there and then to make it work, and then we don't always clean up our code. That's another thing that will lead to bloatware, because we throw something in to test it out, and then we don't take it out of our systems or anything. And just like Ken Thompson, like this kind of relates to him with the Unix, and he's like the father of computer sciences and all that stuff. Where he said, one of my most productive days was when I threw out 1,000 lines of code.
Right.
Meaning that like we all throw those things in there, and if we don't get rid of those, it leads to that bloatware. It leads to overhead that we don't need to be using. So we got to try to do better at cleaning up our code, but again, making it flexible enough and scalable enough for our users.
So sometimes, and I've run into this back when I was programming some time ago, that you don't realize when you're writing the code, you don't always stop to test it or stop to see how is this going to impact the processor? How is this going to impact memory until you've gotten to the point where you're almost done. And then you realize, you've hit some limitations, or the way I've written this may be a little bit verbose or a little bit, even though it works and even though it made sense, it, it, it tend to be very weighty versus being more optimized. I'm also a believer of striking a balance there too. Code that's too optimized is too hard to read and understand, especially if you go back to it a long time. Have to revisit it from a long time in the past.
I agree. And also, a very optimized code is limited in scalability. So if
Yeah,
you need to scale it, it becomes very hard. And I mean, especially in higher ed where I'll have 100 classrooms, I need to be able to scale as easy as we can. So I can see the benefit and the cons both ways.
absolutely. Um, I think some of this will may work itself out as we move forward into doing more modern programming and be able to access libraries and be able to have more proven solutions and functionality to do things rather than having to create our own. But I think it's a good conversation to have because a lot there are many times when something gets written and it gets put in the field and you don't realize what how it's going to perform because it looks different when you're actually writing it.
No, and like you said, this is a good conversation. And also, I think this is a conversation and a topic that will never like go away. Like it's always going to be there. It's everyone's going to have their opinion, and like I love to hear what our listeners have to say on this topic as well. Because, like I said, like this is not a topic that starts and ends with this episode. It's going to be an ongoing, probably long after we're gone, Steve, that this topic is still going to be talked about.
Absolutely. Yeah. It's inherent in code writing. So please let us know what you think. How do you write your code? How much do you worry about as you're writing it? How efficient it is? How streamlined it is? Have you run into problems where it's become too much of a drain on a processor or on memory? Is bloatware a thing for you? And if you're the only one looking at your code, does it really matter? So be good to hear. These are good questions to have our audience follow up on us, follow up with us on. So please take that opportunity and let us know. James, how can people get in touch with you? How can they continue this conversation and keep up with what you're doing?
Again, if you Google me, you'll find me. I'm out there. I'm on X as AP underscore James King, LinkedIn, higher ed writer for the IT and AV column, HEPMA. Again, I'm out there.
Absolutely. And for me, you can reach me at Steve Greenblatt on social media, my company Control Concepts at controlconcepts.net. But what's most important to us is that you keep tuning into this show, and ways to do that are on YouTube. You can see the video version. You can have the audio on your favorite podcast player. And we really like your feedback. If you would share your favorite episode, let us know what you think. Let us know what we need to talk about more or less. And also put your questions out there. That's what we're here for. As the title says, Ask the Programmer. And until next time, this has been Ask the Programmer.